Hello everyone, welcome to this video. This video is for the Lab 11 CCW demo. Right. Of course, CCW is the software we use to program the PLC. It's the short name for Connected Components Workbench. Right. I'm going to talk about how do we create a new project with the simulator. So we don't have a real controller, so we have to use the simulator to test our logic. Then we'll talk about the interface and also the controller variables. Right. They call that variables in CCW. Also, it can be represented by we use tag to represent the data in the PLC, and also you can use other term like symbols or address. Right. The other two topics I'm going to talk about is that how do we set up the communications, and before we can download to the simulator. And after that, I'll focus on the instruction demos. So the typical instructions we learned so far: bit instructions and double integer, and for the instruction move, mass, and compare. Of course, the timer and counters. All right. So let's just start demo. I think the software installation already sent the YouTube link to you, right? I won't demonstrate for that because in that video it's pretty much has all the details you need to know: where to download, how to download, and also how to install it after you have the file. Okay, so we're gonna create a new project from here. So they give you the default name, project 1. You will just take it. If you want, you can change it. So after you create the new project, first thing they want you to select the device. All right, so you can choose controllers, drivers, and other type of devices. First, we want to focus on the PLC. The simulator is underneath the Micro 850. The last one is the simulator we can use for this software, right? So we just need to select it, SIM simulator, right? So select that and add to project. So the software will automatically set up the default settings of the controller, and on the left hand side you see the similar interface with Studio 5000. So we have a project organizer, and then they have a tree structure with different nodes, right? So over here we have the Micro 850, and that's the information in the center of the screen. Of course, you can also have the program. Later on you can add it on here, right? So once we create the project, if you want, you can have a look at the simulator. So I already have the toolbar set up that day. You just need to move the cursor to the icon to find the tooltip. It says Start Micro 800 Simulator. Right? So if you couldn't find it on your toolbar, maybe it's different from mine. You can also go into menu, go to tools, and then you will see the simulator over here. So it's the same. You can see the icon is the same, almost the same. So once you click on that, it will show up this simulator interface. Alright. So there's a power on button, so you can press that to turn it on. Right. So on this interface, you can see here on top it has 28 input on top, right? At the bottom you have output from 00 to 19, so 20 outputs. And notice here it has the IP address 192.168.2.15. Your IP address may be different. It just depends on your laptop. It happened to be my laptop's IP address on my home network, right? And notice here there's a file information. All right, so when you double click this, it shows you that the program scan time exceeds the watchdog timeout value. Right, watchdog is just a timer. Right? Very likely it's because last time when I use it, there's some problem in the program, and then the program going to somehow longer than the value set up. In the later I will show you that how do we solve this problem. I think maybe it's typical for you to run into this problem because the value set up is too low. We need to change that. All right, so that's the so that's the interface you see on the simulator. So I'll just move to here. Okay, so on the tree structure here, there's another node called global variables, right? So if you double click, that will show up all the existing data with the simulator. So at the beginning you can see here with the address you can kind of figure out what they do. So it's a input output emulator. I'm not sure about EM. Digital output 00. So you can see here it counts from 00 all the way to 19. So that's exactly match the output on here. So each one of them is mapped into this output tag. So after that, start from here is the digital input. Digital input from 00 to 27, altogether 28. So that's basically all the output and followed by the input tags from this simulator. And after that, you will see a list of the system variable, right? They call SYS VA. So remember we talked about the watchdog. It's here, right? So the default setting is only 2000, and I'm not sure about this. It's U double integer. So whatever it says is the software watchdog, right? So over here, I think I can just add more zeros to make it longer, because it's a software simulation. Sometimes because the computer is busy, your program may need more time to scan, to go through one PLC scan. So that's why we want to make this number bigger. Hopefully that will solve the problem. Right? So that's the basic setup with the emulator. Right? So the next step, I'm trying to download to this simulator. Without anything I haven't programmed, I can still download. And with download, hopefully we can fix this problem with fault. Right? Over here, when you try to download, go to communication, then you will see here, very likely you will see the same as before, RSLinx Classic. That's the same software we use in the lab. Currently you can see here that nothing is configured, so that's why very likely you're going to do this by yourself at the beginning. So remember I show you the interface on here with the Ethernet IP address. So that's why we need to set up your RSLinx with the Ethernet IP driver. Right? It doesn't matter if you have the wireless or cable net connection or any other one. So if you have the IP address, so you need to choose this category. So add new, then that's the default name. We'll choose that, and then you can see that's the list. You will find your IP address, which is the same IP address we see on the simulator, right? So it just happened that it's the same IP address represents your computer and also for the emulator. All right, so we click OK. It's running now, so we can close it, and you can minimize it if you want. Then we go back to the communications device over here. Yeah, so it's fairly new to me as well, this software. So we can choose download, and then I think, yeah, it's running. It just won't. Okay, similar to the Studio 5000 or RSLogic 500. So you see this like a Who Active interface, right? So you choose the IP address, and that's the simulator. Click OK. Then at the bottom here, that should give you some response. All right. Yeah, you can see here controller is faulted, right? So we have a problem. Continue with download will clear the file information. All right, so it's good. So we want to do that. So click yes. We just confirm with download. See what happened. So notice here on the emulator, the file information disappeared. Right? And in the same time, you can see here it's on the remote on the controller. Download complete. Change back to run. Click yes. So in the same time, you should see, yeah, that change. Notice here. So your controller is on the remote position and also in the run mode. Right. Of course, you can set up to program mode later on. Okay, so also on the top, on the toolbar, you can see here it's connected. So that means we can connect to the emulator now. So once we connect it, so for example, if we look at those input, output, so I'm trying to find input here. You see here, digital input, that'll be the first one. So now I will go into the simulator, try to click this button. You can see here that match this address. Hopefully we can see some value change on here. You can see here, I'm not quite sure with the difference between local variable or physical variable initial values. So, but anyway, we can try that. You can see here, once I click on, and the indicator is on. But on here, on the software, yeah, it finally show up. You see here, the check mark, right? Probably because my laptop is running slow, and it will take some time. If I click that again, that check mark should be disappeared. Yeah, so you can see the simulator is talking to the CCW software now. Right? So if you need some sort of input/output, you can use those address and in your program. Right? All right. So now I finished this one, simulator interface, controller variables, communication finished. So now we can just move on to this one, the instruction demos. All right. So to do that, maybe I want to do that offline. So just click here, disconnect. So once we disconnect, right click on the program and add. You can add your program in 3 different programming languages. One of them is the LD, ladder diagram. That's the one we want to use. So once you create on that, you can see you also have option to create local variables on here. Right. Let's just open this on the PROJ1. So you similar interface on here. So you have one run on this, and on top you have instructions. Right. So you can click and drag into there. So for once you drag into there, they give you the variable selector. All right, that's one way you can select the variable, or you can create new. So if you create it over here, you click here, you can create new. Or if you click on the upper half, you will see similar to Studio 5000. That's the selector for the for your tags. So for example, we want to use the first input on the simulator. We can click on here. Then as output, we can click and drag, and I wonder if I can choose from here. IO, yeah, that's IO tab. You can see here. You can also click on here. And if I just want to use the let's just say number 3 output, let's just say choose number 1 output. Doesn't matter which one. So if I click on it, so that automatically signed to the output instruction. So now I can click download over here to transfer my program into the simulator. So it will take some time to start the download. It shows some progress over here before, and yeah, that's some progress. And then confirm, go to run mode, and it's running now. And it automatically goes back to the program I just entered in there, right? So you can see that's the simulator interface and also program in there. So this one is the first input, and then if we press that, that should energize the second output, which is here, right? You should see this light turn on when I press this. Turn it on. Same time you see in the program view that I guess the red color represent the logic truth. Then if you those input is almost likely a maintained push button, right? So if you press again, the button release, then you should see the same response on the program. All right. So it just show you that if you want to connect to the input output with simulator, you can use buttons as input, and you can see the light at the lights as output with your program. Alright, so let's go back to the program to see what else we can do with the logic. So for this one, for example, I want to design a not this. If I want to start, for example, I want to program a 3-wire control, right? So over here, I can create variables, right? So like within the memory. So for example, I can call that stop, like stop button, right? So if I click OK, that shows over here. That's it's not input output. It's just a variable I created in there. After that, I can use so over here, double click. I can create a new one. Start. Click OK. And output, if I want, I can name this as motor. Alright, so with 3-bar control, I can have a branch, and I haven't quite figured out. So we can drag this into here. Right. So now at the second branch, we can program that. I don't know if I can drag and drop. Oh no, that doesn't work that way. Okay. So over here, I guess maybe I just need to type in motor. Yeah, it's already on the list. Motor on here. So I can program my logic by using the variables I created within the memory now. Okay, so that's for the bit logic, right? And if we want to program double integers, let me see here. Create a new run over here, and that's different category of the instructions. So you can see here we have a bit logic. We also have the math, the operations, and compare, and move. So that's the same category we learned in the Studio 5000. Let's just try the move first. All right, so if I drag a move instruction on here, it looks a little bit different from Studio 5000, but they should work in the same way. So for example, I just use a push button as a trigger. So for example, remember in the lab we call the push button move 1. Right, so if we just name that same way, and let's look at this instruction. So if you don't know what exactly the instruction what it does, and if you want to know details, highlight the instruction, press F1. That should open up the help file. So you can see here move instruction, all the information you can look at here, right? So one thing I'd like to talk about with the Studio 5000 with the CCW is that the instruction format you can see here with that, in my personal opinion, is very similar to Siemens style. So I guess maybe this is the what Rockwell designed to compete with the Siemens PLC, because Siemens is also very popular, and they have a lot of customers. If they want to program in a similar style, so they have to use similar format, right? So that doesn't matter for us to learn that. So you can see here. So this type of instruction is very similar, because always you have an input going to that instruction. Then you have another side as output to go out. So in this way, you can put instruction after one after the other, right? So it's like a chain. And in addition to those two typical input-output, you will have a input-output associated with this instruction. So for example, here it has, I don't know, it's called I1, O1, right? So I1 is input, right? Input, we can type in to be safe. Let me input. Let me look at the help file again. So let's look at here. You can see here I1 input, right? You can have all these kind of, wow, there are lots of data type you can set up as that. I want to focus on this double integer, right? So you can see double integer is there. We can set up as double integer. also output 01. Yeah, my software starting to acting up. Probably I should maybe stop very soon. Output you can also set up as a double integer, right? So we'll just use this instruction to work on our lab, right? So for example here with double integer, for sure I can set up a value. So for example, I just type in 1, it should be alright. Yeah, there's no error here. Then on this I can set up a integer tag. Right, so for example, I will call that int1, and the type I want to use the double integer type. Then click OK. So basically, if you have this button being pressed, or you have this tag variable Boolean variable value as 1, this move instruction will become true, and that will move the value 1 into int1. I'm going to download and test the program. Download. Yes. Okay, so it's running now, and so for example on this 3-wire control, right? So the stop button, if it's normally closed, that should be value 1 now, right? So we can simulate that if you right click, toggle, right? So that becomes red, right? The other way you can do that, not only you can see here Control T. That's exactly the same shortcut with Studio 5000, right? So you can highlight. I'm going to press Control T, and then motor gonna energize. And if you highlight stop, Control T, motor gonna stop, right? So I forgot to toggle off. So start should be toggle, should be off. So that. But anyway, so that's the typical 3-wire control. Then let's look at here the move instruction. So we have int1, the current value is 0, right? We want to move the immediate value 1 into this int1 variable. That followed by this trigger. So I'm going to press Ctrl T on my keyboard, and then the value int1, the tag will be changed to 1. So if I toggle this button off, so you can see it acts in the same way as Studio 5000. Even though the trigger is off, the value stays there as 1. Right? So that's the same way as the Studio 5000. All right, I think I need to stop here as the part 1. We'll have more instruction demo after this video.